Hello online students, welcome back to physics lesson. Today we will see projectile motion equations. In the past lesson, the robot showed you the introduction and some simulations of projectile motion. Today we see different cases of equations. Okay, this is advanced course on projectile motion. Let me show you one by one. In general, we see the first case here. Let me show you. Here is the case. The first case, we see case 1. You see here. Okay, this one, case 1. Horizontal projectile, no angle, when the object is projected without any angle, just horizontally from a certain height h. This is the first case. The second case, when the object projected from the ground. That means directly from this side to this project from the ground. The previous from a certain height horizontally. The third case, when the object projected upward above a height. That means we are assume we are a certain height from this point to this point. We are, for example, 5 meters. Okay, then from this certain height, the object is projected upwards. That means like this, upward project, and then goes to down. This is the third case. The last case, projectile motion at downward angle. That means in this case the object is projected downward from a certain height h. For example, we are here 14 meters. We have this 14 meter high, and this object, assume we have this object projected from certain height, okay, down, but it makes angle, an angle theta. Okay, an angle theta. So we'll see this case. Okay, now let's start from the first case, which is the object is projected upward horizontally, okay, with no angle. That means in this case, okay, let me show you one simulation and you will understand what does it mean horizontal projection. Okay, but before that, we know that projectile motion equations, the core assumptions we have here, the projectile motion equations. One, the acceleration due to gravity is constant. It can be 10 meters per second square, or it can be 9 meters per second square. This minus this per second square. Okay, no need to confuse. Okay, the other, the horizontal acceleration is that. Okay, that means I write here that no horizontal there is no horizontal here. You see, there is no horizontal acceleration. Okay, don't forget these assumptions. The effect of air resistance is negligible. Okay, we have to neglect air resistance, because if there is a resistance, it doesn't work. Okay, so these are the assumptions. Let me show you what do you mean by horizontal projection. Here, horizontal projection. Okay, That means without any angle. Let us see one simulation. Alright, here is the horizontal projectile motion. That means without any angle. That means the object is, look, starts from this and then, okay, down, makes, okay, without any making any angle. Okay, this is the horizontal and this is the vertical motion. Okay, or we have the horizontal on the x and we have the vertical on the y. Okay, without any angle. Okay, so such kind of motion is horizontal project. Okay, so for this case we have different equations, so let's drive one by one. And this for horizontal projectile case, as we said, no angle. Okay, just horizontal. Okay, project like this. Okay, until the object arrives here. Now here we have two cases, one the horizontal case and the vertical case. For the horizontal direction, the initial velocity always constant. Okay, that means the initial velocity is constant. This implies for the horizontal, this we are talking about the horizontal. Okay, for the horizontal, the initial velocity constant. This implies the acceleration is 0. We don't have any acceleration. Ax across the horizontal is 0, because for the horizontal we have dx, for the vertical we have minus dy. Okay, and the horizontal displacement, let's say we have sx. Sx means this x, or sometimes we can't say d, sometimes you can say as r, which is the range. Okay, range. So we have this case for the horizontal. For the vertical, we are considering vy. Okay, this one, the horizontal, always the x. Okay, vy is equal to 0. That means the initial velocity across the y is equal to 0, because initially project this object, for example, this object projected with initial velocity initially. Okay, but after a certain point, okay, after a certain point, the final velocity across the y is not different from 0. Okay, don't forget this. Again, the acceleration ay, means the acceleration across the y is equal to negative 9.8 meter per second square. It is equal to, we can say, the gravity, because the vertical motion is due to the effect of the gravity. That means the object accelerated downward with acceleration due to gravity is g. Okay, in the vertical direction. All right. So we are going to derive equations for the x along 1. Let me write here let me say 1 along x-axis. Okay, along y-axis. Okay, uh, and in kinematics we know that the final velocity is given by the initial plus acceleration times time, and the displacement, this one the displacement, or you can say the displacement s, or the x final, can be calculated by the initial times t plus 1 over 2 8 squared. This already we know in kinematics. But in projectile, the acceleration we have negative g, and we substitute each case. Okay, that means the initial velocity, the final velocity, everything. Let us see. For the x-axis we divide for the x and the y. Okay, let's see the first case. The final velocity, across the x is equal to, we can substitute what the initial velocity across the x, because when the object is initial projects, it has its own initial velocity across the x. Okay, plus, because we are in x-axis, okay, plus the acceleration, we have only the acceleration toward the horizontal, which is equal to 0 times t. Let's say t, okay, because for horizontal projection, the horizontal velocity is constant. That means the acceleration is 0. We already said here, okay, the horizontal acceleration across the x is equal to 0. We already agree with this. Okay, because when the velocity is constant, means acceleration is equal to v final minus v initial over t. That means the acceleration is equal to constant, means v initial is equal to v final. Okay, v final is equal to v initial. That means let's say v final minus v initial is equal to v final over t, which is equal to 0 over t, which is equal to 0. That's why for constant acceleration, and for constant velocity, the acceleration is 0. Then in this, along the x-axis, we have the final velocity across the horizontal x. Don't forget to write x, okay, is equal to v initial across x, t times t, which is 0 times t, which is equal to 0. That means always the final velocity is equal to the initial velocity. Alright, what about in the along the y-axis? Along the y-axis, we have to find the final velocity across y is equal to, we are using kinematics, our initial, this equation, kinematics equation, v initial across the y, okay, plus the acceleration due to gravity is minus g, okay, negative g times t. We already at the beginning we said that the initial velocity across the y is 0, because when the object is projected here horizontally, the initial velocity across the y is 0. Okay, now the final across the y, because we are in the vertical, or the y-axis, is equal to the v naught y is 0, which is equal to minus g times t. Good. Alright, what about the direction of the final velocity across the y? That means when the object is here, the final downward. Okay, for downward we know that the velocity is negative, so the motion is downward. Okay, that means for downward we have what? Negative final velocity minus d final y is equal to minus d times t. Then we get this implies finally the final velocity across the y is equal to d times t. Alright, good. The second, the displacement across the x axis at any instant time at, at any instant time, let me say, at any instant time t, let's say. Okay, how can we calculate the displacement? Our initial equation is which one? This one, the displacement. The displacement can be found by the initial across the x times t plus acceleration across the x, because we have to convert to the horizontal. Okay, we are talking about the vertical case. Okay, plus x, no, here we have, sorry, we have 1 over 2. Okay, I forget that, plus 1 over 2, because we are this equation. Okay, this one, the 1 over 2 times acceleration across the x times t squared. Okay, we put all the values across the x direction. Now, or we can write equal to x. You can write, okay, on the x-axis. Okay, the displacement. Now we know that x is equal to the acceleration across the x is 0. We already said the acceleration across the x here there. Okay, means our new question b not initial across the x, okay, times t is equal to plus 1 over 2 into acceleration 0 times t squared. This part already 0. Okay, then the displacement across the x, okay, across the x is equal to the initial velocity across the x times time. This is the second important formula. Okay, what about the displacement across the y axis? Okay, on the y axis, our starting question will start from, instead of x we have what? Y, because we convert this equation. Okay, we are in this. Okay, so y, let me say final, because at this point right, that means the motion is downward, that means negative y, okay, is equal to, look at this equation, you convert x, the displacement is across the y, equal to b naught across the y times t plus 1 over 2. The acceleration only will have negative g times time v square. And the final, that means is equal to, or we can, this one is equal to the displacement final across the y. You can write like this, okay, no problem. Negative y is equal to, we know that for the vertical motion we already said the v initial across the y is equal to 0. So in our equation we know why this part is 0. What's left? Minus g times 1 minus 1 over 2 g t squared. We have minus minus become y is equal to 1 over 2 g t squared. We can calculate the final displacement across the y direction. Across the y direction. This one, okay. Across the y direction at any point here by this equation, okay. Additionally, for the displacement across x means here the total, here we have seen that the range here, okay, the range, this x, the final in this equation, this the displacement across x is equal to the range, okay, can be substituted as is equal to v naught across the x times t, okay. It can be equal to with the range, okay, because we already at the beginning I explained that this we call the range. That means from this point to the point. That means the horizontal distance, the horizontal displacement. And so we can write like as r is equal to v naught x is equal to always v naught times time. This is the equation for the range, or is equal to this equation, okay. From this equation we can also derive the time. It means the time, this implies time is equal to 2 times the displacement across the y over g under the square root, okay. Alright, let's see the net velocity for this horizontal projection. That means we have this at this point, this object is projected horizontally from this point to this point. Let's say r the range, okay, and as horizontal projects with initial velocity, okay, and we have the horizontal and the vertical, okay. At this point we have the vertical and the horizontal vx, the vertical vy, and we have this velocity, okay, at the middle. This velocity we call it the net velocity. Net velocity. This can be calculated by Pythagoras theorem, or we can use a net velocity is equal to net square is equal to v upon the x, the final, time square plus v upon the y square. V next, let's say v is equal to vx. Vx we already calculated here. The vx here always equal to v naught times x. It means we can substitute v naught across the x square plus about vy velocity across the y g times t. v times t the whole square. This implies the net velocity is equal to the square root of v naught across the x square plus v times t the whole square. Okay, this is the formula. We must find both the x velocity and the y direction velocity, and finally we get the velocity at the net velocity at instant time t. Good. If you have any question, please write on the comment section. Alright, let us see this example. An object is launched horizontally from a 35-meter cliff at a speed of 20 meters per second. When it reaches the ground, how far out from the base of the cliff will it have traveled? And calculate. Let me add you also find also t. Okay, find t. Let me sketch here. We have an object. Okay, and 35-meter cliff. That means the object is above 35 meter. Okay, this is in that it will given the y or the total or the height. Okay, no problem. And within horizontal, it's projected horizontal. Okay, that means the object fell or arrive at this position, and we have also this, we call it the range or the horizontal distance or x. Now with initial speed v naught is equal to 20 meters per second. You have given this information. Okay, I add only this one. Then when it reaches the ground, how far out from the base of the cliff it will have traveled? The base of the cliff from here, this point to this point, how far? Let me say A, your required R is equal to how much? And B, find the time. B, your required T is equal to how much? Now solution. We already derived these equations. Okay, look at this equation. We have y is equal to 1 over gt squared, because we have given the vertical distance. That means come here, let's take this equation. Y is equal to 1 over 2 gt squared. If you use this equation, you can find time. Okay, let's find it. This simplifies y, how much? It's 35 meter is equal to 1 over 2. Let us take g as 10 meter per second. Take sometimes g is equal to 10 meter per second square. Take g as 10 meter per second square. This is example. In calculation they will give you. Okay, don't worry. Just for times g 10 meter per second square times t square. Now by 2, 1 by 2, 5, 35 meter is equal to what's left? 5 t, because 2 by 2, 5. Now t square. This implies is equal to the square root of 35 over 5, which is equal to around 6.65, which is approximately, let's say approximately 6.65 second. Okay, you can use your calculator, no problem. When there is exam, they give you some simple numbers that can be divided, or you can take out the square root without any calculator. Okay, don't worry. Okay, good. This is the solution for B. Okay, we already find the time. Okay, but under A you are required the range. Okay, the range means the horizontal distance, because it says how far out from the base of the cliff it will have traveled. Okay, let me write here. So for case A, R, find R, we already derived the formula for R is B initial times T. B initial across the X times T. B initial 20 meter per second. Look, 20 meter per second. It's already given. 20 meter per second times T. We already calculated here. 6.65 second. 6.65 second. The simple as R is equal to, okay, this around 53 meters, which is equal to, also you can say X, or the horizontal displacement. That's all we have for today. If you have any question, you are welcome. Write to me on the comment section or in this messenger. Okay, thank you so much. See you in another lesson. Bye bye.